notice, and this is the typical copyright. We continue with mathematics syllabus for CSEC 2018 and continuing. As of December 2025, this syllabus has not been revised, but there are plans to change the structure of the exam as of 2028 and onwards. And currently, there are a few pilot projects now being conducted in a few Caribbean countries. Note that the syllabus remains unchanged. The two main plan changes are: one, split the exam into two parts, and two, there will no longer be any alternative sections. All sections will be tested. Schedule of videos. By now you already know that these first three sections, all 51 videos, have been published in their entirety on YouTube. Please make good use of them. Section 4, measurement, 5 of those have been published in their entirety out of 17. Section 5, statistics, 5 out of 18 have been published in their entirety on YouTube. Section 6, algebra, 7 of these 22 videos have been published on YouTube in their entirety. We are now at section 7, relations, functions, and graphs. This is the 12th of 26 videos, and hopefully by the end of this month, February 2026, I should have this finished or almost finished. Section 8, geometry and trigonometry, by March 2026. And then finally, section 9, vectors and matrices, by April-May 2026. Please note this disclaimer down here. This schedule is just a projection, and it is not to be interpreted as a contract with anybody. As I said, from section 1, all 33 videos have been published in their entirety, especially since this section forms the foundation on which the rest of the syllabus is based. So you must know this section very good in order to do well in the rest of the syllabus. Reminder, you need to know the times tables from 2 to 12, especially since calculators are not allowed in paper 1. Going back to section 1, some of these videos are even applicable in the primary school for students, for teachers who can use them in the inverted classroom, and for parents who may think they don't have the math skills, and looking at these videos with their children, they would be able to help the children. The students themselves can look at the videos before they do this in class, and then even after class to reinforce the concepts. So even in primary school, some of these videos are applicable. For example, if you consider this blue box here, note video 6 says addition, subtraction, multiplication, and division of whole numbers. And to do that, you need to know about place values, which is an earlier video. And then it talks about addition, subtraction, multiplication, and division of decimals. That's video 7. And video 8 deals with addition and subtraction of fractions. And then video 9, multiplication and division of fractions. And this is type of work that is done in maybe grades 4, grade 5, and grade 6 in the upper section of the primary school. So these videos can even be used in primary school to better prepare students for when they get to secondary school. From section 2, consumer arithmetic, all 12 of these videos have been published on YouTube in their entirety. From section 3, sets, all 6 of these videos have been published on YouTube in their entirety, as I previously indicated. From section 4, measurements, These indicated in yellow here have been published on YouTube in their entirety. The others are only partially published. Please see directions in the description below if you want to have full access to these videos that are only partially published on YouTube. Section 5, Statistics. These videos indicated in yellow here have been published on YouTube in their entirety. The others are only partially published. Again, the same principle applies. Please see directions in the description below for full access to these videos that are only partially published on YouTube. Section 6, Algebra. These 7 videos have been published on YouTube in their entirety, and that is because many learners seem to have problems with algebra especially. So you have these 7 videos published in their entirety, and then the others are published partially, but even from those that are published partially, you can still learn something from it because they do deal with some aspects of those objectives. However, if you want to have full access to these videos that are partially published on YouTube, please see directions in the description below. Section 7, Relations, Functions, and Graphs. This section has 26 videos, which we are looking at right now. Before we go on, recall I said in the introductory video that you will need a good math textbook or a set of 2 to get especially more practice questions. CSEC recommends these on the right here. From those, I would recommend these last 2 here, especially since they form a very good 2-volume set of math textbooks that is quite adequate for the current and the future proposed changes in the structure of the CSEC math exam. This is volume 1 by Raymond Tulsi, and this is volume 2. Please note this disclaimer down here. I get no financial or other benefits from the sale of these books. Also, there is a website with AI interactivity. It's free of cost that deals with past CSEC math questions only, specifically from paper 2. It is important that you become familiar with how CSEC sets its questions for paper 2 and what will be considered good or correct answers to such questions. This is the URL for that website. And this is the website here, the home page of the website. You register first and subsequently to that, sign in. But remember, I said it is free. Again, that's the URL up there. This URL will be in the description in this video below. A reminder that this formula sheet you see on the left here will be provided for the CSEC math examination papers. This formula sheet is included in the full syllabus. If you don't have the full syllabus, then there is a link in the description below from where it can be downloaded. This is the top part of that formula sheet, so you could see it better. I am going to state the obvious here. You do not need to memorize these formulae on this formula sheet, as this sheet will be provided during the examination. And this is the below part of that same formula sheet. But you do need to know when and how to use these formulae, even if you don't have to memorize them. So section 7, Relations, Functions, and Graphs. We completed all 5 videos on this page, all 5 objectives. Next page, up to objective 9. All of those have been completed. Next page, which will take us up to objective 13, but we are not there yet. We have completed objective 10 and 11. That's this and that, which means that we are now here, objective 12. Continuing with the preview of the rest of the section, that would take us up to objective 17. and then up to objective 20, up to objective 22, and finally up to objective 26. This brings us to the end of this section. 26 objectives, and therefore I have arranged that as 26 videos. So let's get back here. We have completed up to objective 11. These have been published in their entirety, and these others only partially published. When this one is finished, video 12, it will be published in its entirety, the complete video. So objective 12, and it states, solve a pair of simultaneous linear equations in two unknowns graphically. And you are to do that using intersection of graphs. Now, to solve simultaneous linear equations graphically, you will plot both equations on the same coordinate plane, the graph paper, and find the point where the two lines intersect. You have seen this before. So this is mainly review, but it is a specific objective, so I will deal with it here. The coordinate, that is the x and y value of this intersection where the two graphs meet, is the solution to the system of equations, as that point will meet the requirements of both equations. In this video, we will consider 6 such examples. So example 1, solve graphically for the linear function y is equal to 3x minus 2. We will call that equation 1. And the constant function y is equal to 4. We will call that equation 2. We know other ways of solving simultaneous linear equations, but this one says we are to do it graphically. So we get a table of values, which would be the ordered pairs. So for x, we will have the domain values, and we normally take from maybe 5 to negative 5, and then we calculate the range value based on the functions or the equations we are given. So we now have ordered pairs. So for negative 5, we have negative 17 for this equation, and for negative 5, we have 4 for that constant function there. So now, let's consider all of those. Keep in mind that you need a minimum of 3 points to plot the straight line graph. You don't need all of these you see here on the left. But the more points you calculated in the table, you may actually see the answer in the table itself. Now, because I'm using Microsoft Excel to get these ordered pairs, it's fairly easy for me. Once I entered the formula there, I just drag it down or here. So it becomes easy. But if you are in an exam, you may not be able to have all those points. Now, as it relates to seeing the answer in the table of values, look at this here. 2, 4, and that same 2, 4. So based on the table of values, we know the answer. Let's go do this graphically. So we plot the two graphs here. Y is equal to 3x minus 2, and y is equal to 4. Where do they meet? At this point here, which is 2, 4. That is to say, the x value is 2 and the y value is 4. Once you have that, please verify your answer. So if you put in the first equation 4 for y and 2 for x, notice on the left hand side we have 4 is equal to 4 on the right hand side. So at least in that equation 1, it works. But then the second one, y is equal to 4, substitute 4 that we got from the graph, and we have 4 is equal to 4. So we know that this point, 2, 4, at a value of x is equal to 2 and y is equal to 4, that satisfies both equations. If you find this video useful and interesting, please like and share. That is to say, like and share. You may also consider subscribing to this channel. Example 2, solve the simultaneous linear functions or equations y is equal to 2x minus 5 and y is equal to 7 minus x. And you are to do that graphically. So we get table of values or ordered pairs. We choose some numbers for the domain, and then we get the range according to these functions here, these equations here. Remember again that you need a minimum of 3 points for straight line graphs, not all of these that you see here. However, the more points you calculated in the table, you may actually see the answer in the table. For example, notice this 4 here with a 3 there, and that same 4 there with the 3 here. So we know that the answer is going to be 4, 3 from the table. But you may not be calculating all of those points. You may just calculate 1, 2, and 3 and plot your graph. And then look to see where the two lines intersect, which looks like this. The two lines intersect here, and that is 4, 3. Going up 4 here, coming across 3 there. So x is 4, y is 3. Now we will make sure that that answer is correct by substituting those numbers in each equation. So y is equal to 2x minus 5. We substitute 3 for y and 4 for x. And we get 3 on the left-hand side is equal to 3 on the right-hand side. So we know that in that equation, it works. Let's try the other equation. Again, we substitute 3 for y and then 4 for x. And we find that we have 3 on the left-hand side is equal to 3 on the right-hand side. Now, you may not get the same 3 here as down here. You may get different numbers, but that is not the issue. The point is, the number on the left-hand side, is it equal to the number on the right-hand side? So we know that the solution to this question is 4, 3. Example 3, solve the simultaneous linear equations 5x plus 2y is equal to 40. We'll call that equation 1. And 3y minus 6x is equal to 33. We will call that equation 2. We will solve that graphically, which is what the question says. So again, you get your table of values or ordered pairs. Here, the x value would be the domain values. And then for each one, we will calculate the range value. So we get these range values here and here, depending on what the equation is. Again, note that you need a minimum of 3 points to plot a straight line graph. In an exam, you may not have time to get those 13 points you see listed here. So you may just choose -5, 1, and 6. However, the more points you calculate in the table, the more you are likely to actually see your answer in this table. And in this case, the answer is 2, 15. So let's look at a graph. There are the two graphs. Y is equal to 2x plus 11. Well, over here I have it as y is equal to 11 plus 2x. But the computer program changes it around. Y is equal to 2x plus 11, no problem. And then the other one, y is equal to negative 2.5x plus 20. That is this one. And the point where they meet here, where they intersect, is 2, 15. That is to say, On the x-axis, it is 2. On the y-axis, it is 15. So 250. So the solution to the equations would be x is equal to 2 and y is equal to 50. Let's test that answer. 5x plus 2y is equal to 40. We substitute 2 for x and 15 for y. And we find that we get 40 on the left-hand side is equal to 40 on the right-hand side. So we know it works in equation 1. Let's try equation 2. We substitute 15 for y and 2 for x. We work that out and we find that we get 33 on the left-hand side is equal to 33 on the right-hand side. So it also works for equation 2. Now remember I said, even though we get 40 here, we don't need to have 40 down here. All we need is that the left-hand side is equal to the right-hand side. So we know that this is the solution. Remember, you are solving. We know that's a solution for that pair of simultaneous linear equation. Example 4, solve the simultaneous linear equations. Y is equal to negative x plus 6. That's one equation. And the other one, y is equal to 9 plus 2x. We will designate that as equation 2. So we will get our table of values or ordered pairs. Normally you may be given these values. If not, you would take from 5 to negative 5. But since they are linear equations, you may not take all of those points. You may just take negative 5, 0, and 6. Because that would be all you need to plot the points once you get the range values. So negative 5, 11 for that one, 0, 6, and 6, 0, and so on. As I said, you need a minimum of 3 points to plot a straight line graph. But the more points you calculated in the table, you may actually see the answer in the table. And as I said, because I am using Microsoft Excel, it's easy for me to do that and show you all these points. So look at what happens here. Negative 1, 7, negative 1, 7. So if we had the ordered pairs, we actually know the answers. But the question says to solve those simultaneous equations graphically. So here are the two lines. Y is equal to negative x plus 6. That's this one here on the left. And this one up here, y is equal to 2x plus 9. Well, the software switches it around to 2x plus 9. We have here 9 plus 2x, same thing. Where do the two lines meet? Here, which is negative 1, 7. That is to say, this point here is negative 1, and over there is 7. 5, 6, 7. So let's test our answers. When y is 7 and x is negative 1, we have 7 on the left-hand side is equal to 7 on the right-hand side. So it works in that first equation. Let's try the second equation. Y is 7 and x is negative 1. We simplify that, and again we get 7 on the left-hand side is equal to 7 on the right-hand side. So once the left-hand side is equal to the right-hand side, they may not be the same number in both equations, but if the left-hand side is equal to the right-hand side when you substituted the numbers, then you know that the solution works in both equations. Example 5. Solve the simultaneous linear equations. Y is equal to 2x plus 6, we will call that equation 1, and y is equal to 1.3x minus 1. We will call that equation 2. We will have to solve it graphically. So by now you know that we get our table of values or ordered pairs. This will be our domain values, and these will be our range values based on the equations we have. If we plot the graph, this is what happens. And remember, you don't need all of these points. You just need 3. But even with the 3 points, let us say this one here, that one there, and that one up there, the 2 extreme points, -6, 6, and another one somewhere in between, say 1. Even with those, we can see that the graphs do not intersect. So the lines are approaching each other, but do not intersect based on the domain, that is to say the x values chosen. So what we need to do is to decrease the negative x values and maybe the positive x values as well. So let's decrease the x values from -6 to -12. Remember, -12 is a smaller number than -6. And from 6 to 1. Now, if we do that, this is what happens. Well, you notice here where it says -10, we have a -14 here and the same -14 here. But previously we were going up to -6. So we missed that point. Now, if you plot those points, this is what you get. And again, you don't need all of those points, just 3 per straight line graph. So they intersect here. Now the lines intersect, and we have an answer which says -10, -14. So x is -10 and y is -14. That will satisfy both equations. Let's try it. When y is -14 and x is -10, notice -14 on the left-hand side is equal to -14 on the right-hand side. So we know that that works in equation 1. Let's make sure that it also works in equation 2. So y is -14 and x is -10. We get -14 on the left-hand side is equal to -14 on the right-hand side. So we know it also works in equation 2. But remember what I said. We got -14 here. That doesn't mean that we have to get -14 down here as well. What it does mean is that the left-hand side must be equal to the right-hand side in both cases. So if we plotted just those 3 points, you need a minimum of 3 points to plot the straight line graph. So we are just using 3 points. Notice you end up at the same point here, which is -10, -14. Just to show you that we really don't need all of those points. Just 3 points per straight line. Finally, example 6. Solve the simultaneous linear equation 2y is equal to 3x minus 7. We will call that equation 1. And 6x plus 4y is equal to 4. We will call that equation 2. Solve that graphically. All right. Before we get the ordered pairs, let me point out that this is a trick question. If you convert each equation in the format y is equal to mx plus c, you may actually have seen this already. Y is equal to mx plus c. Notice their gradients m. Here it is 1.5 and here it is 1.5. So when the gradients of 2 straight lines are the same, then obviously those are parallel lines. They are never going to meet, no matter which direction you project them. If you project them down to the left here or up to the right there, they will never meet. Why? Because their gradients are the same. They are parallel lines. So as I said, that was a trick question. As simultaneous linear equations, they have no solution. So that is why this simultaneous here is in quotation marks. And that brings us to the end of Objective 12, Section 7. Solve a pair of simultaneous linear equations in two unknowns, x and y, graphically. And we are using intersection of graphs. So that brings us to the end of video 12 based on Objective 12 in Section 7. This is just an overview of how the videos from this section will be published. This is video 12. This is published in its entirety.